Creating digital signals. Digital signals are created to represent various types of information. It can be text and computer instructions. They're composed of characters, letters, numbers, or other symbols. It can also be analog signals, such as a physical measurement where you're doing the weight or temperature, or sound or images. If you'd like to send your friend the message, "See you later," you have a number of choices. You can leave them a written note, you could record something, you could send them a text message. But the point of this slide is the words are composed of letters. These are just shapes. We see these shapes, and because they're shapes, we will call them analog. Every character, whether it is a letter, a digit, a symbol, or a special non-printing character that instructs a computer, is sent as a binary code. There are a number of common codes. The most common is the Ascii code. In Ascii, each character is associated with an 8-bit or 1 byte, right? The other name for 8 bits is 1 byte. The original Ascii code was 7 bits, but needed to be expanded for modern computers. So the 7-bit version has 128 characters. And what would the 8-bit version have? 256. So you can see as computers get more complex and capable, they need more characters. So that's why the 8-bit version would be used there. We're going to work with the 7-bit version to illustrate how this goes on. Here is the Ascii code, and even though there are 8 bits in every code, we call this the 7-bit code. Why? I don't know if you can see it too well, but here's a decimal. This is 0. 0 is represented by 8 zeros. That's the binary code. Right over here, this is our decimal code. Down over here, we have 31, which is 0 followed by a couple zeros and then ones. The point here, everything has a 0 in front of it. So if everything has that 0, we really don't need it if we're just using 7 bits. So each code has 8 bits, which of course is 1 byte. But the first one is the same for everybody. If we could change that, have a 0 or a 1, we could double the amount of codes. So we'd go from 128 to 256. And here we've taken a portion of the table just to make it a little more visible. The standard Ascii code table has 128 characters. The first bit of each code is a 0. For the 8-bit version, which is called extended Ascii code, the first bit could be a 0 or a 1, and then you'll get 256 characters. Here you can see how zeros, that's all we have for the first character. The first 32 Ascii characters have names. We don't see numbers there. We have null, SOH, STX, ETX. Those are machine instructions or non-printing characters. When you send a text message, the letters are converted into Ascii code before being transmitted. At the other end, the Ascii codes are converted back to letters so your friend can read it. So let's look at the message again. See you later. So here we go. We have the letter S. We look over here at our little Ascii code sheet, and S is represented by 1110011. There it is. E is represented by 11000101. Remember with Morse code, E was a dot, okay, because that's the most used letter. So this might look simpler, but this is easier to implement with computers. Then we have this one. The 0, 1 followed by zeros, that doesn't show up over here, but that is a code for a space, because we have spaces between our words. And then finally, this special code says, hey, we're done transmitting, go ahead and read it. So we use the non-printing characters. Non-printing characters would be A, B, C, it would be numbers like 3.14, stuff like that. We use the non-printing characters for spaces between words to end messages and also specific computer instructions. And here's how it would be transmitted. Notice there's no spaces in there, either between the words or the sentences or any punctuation. It's just a stream of ones and zeros. And all of that is the same thing as saying, see you later.